Guys, let's do page 7 and 8 tonight. Okay, so on number 28, just a regular old integral. Excuse me, you do need to do your u sub on this one. So on this one, let's let your u equal x plus 1. And then your du is going to be 1 dx. And then rewriting this integral. So you're going to get the integral of, don't forget to change your boundaries. So if you plug the 3 in, you're going to get 3 plus 1, which is 4. And if you plug the 0 in, you're going to get 0 plus 1, which is 1. And then doing the u sub, you're going to get u to the 1/2, and the dx is going to become your du, and there are no leftovers. Okay, so integrating this, if you add 1 to this, you're going to get u to the 3/2. And then divide by 3/2 or multiply by 2/3 and evaluate that from 1 to 4, which really means 2/3. And then this is the square root of u cubed evaluated from 1 to 4. And then plugging this in, I'm like running out of room here. I'm going to continue it down here if that's okay. This is going to be 2/3 the square root of 4 cubed minus 2/3 the square root of 1 cubed. Okay, so you guys, when we do this, remember 4 cubed is 64, the square root of 64 is 8. So this is going to be 2/3 times 8 minus, and then all of this just equals 1, so minus 2/3. So I have 16/3 minus 2/3, which is 14/3. So the answer should be D. Okay. All right, looking at number 29. It says, now it's telling you what the u is in this one. So it says let u equal x over 2. And then they don't want you to evaluate the integral, but they just want you to do the u substitution. So if your u equals x minus 2, I'm sorry, x over 2. You guys, that's just a fancy way of saying 1/2 x, right? So the du is going to be 1/2 dx. Okay, so when I do the substitution, first I have to replace my boundaries. So if I plug a 4 into here, 4 divided by 2 is 2. And if I plug a 2 into here, 2 divided by 2 is 1. And then if I do the u sub, I'm going to get 1 minus the x over 2 was the u, so it's going to be u squared. Okay, and then you get all over x dx. Okay, now here's the problem. The dx is going to become your du. So I can go ahead and change this to integral from 1 to 2 of 1 minus u squared over x du. And then I have this leftover 1/2, which means I have to multiply the whole integral by 2. Okay, now you guys, again, the issue is this x. Like, what the heck do I do with this x? How do I get rid of that? So the one thing that you could do with this is find out what x actually equals in terms of u. So if I look at what the formula I had where u and x were related, so I had this equation, u equals x over 2. If I want to find out what the x actually equals, if I multiply both of these two by 2, I'm going to get that x equals 2u. So I can actually put that in there, giving me that this is now going to be equal to integral from 1 to 2 of 1 minus u squared all over 2u du. Now everything's in terms of that u. So let's see if any of those are actually the answers. And it looks like it's actually C. Okay, so that was kind of a tricky one. We haven't really done that much. I did not put on that test for tomorrow, okay? Or for Thursday, sorry. Okay, number 30. If the integral from -2 to 2 of x to the 7th plus k is 16, then what is k? Okay, so let's just do it. Let's find the integral from -2 to 2 of x to the 7th. So the integral of x to the 7th, no u sub here, is x to the 8 over 8. The integral of k is kx. And you're evaluating that from -2 to 2, and that should equal 16. Okay, now plugging this in, so we're going to get top minus bottom, right? It's going to equal 16. So if I plug in the 2, I'm going to get 2 to the 8th all over 8 plus, and then if I plug the 2 into here, I'm going to get 2k. And then if I plug in the -2, I'm going to get -2 to the 8 over 8 And then if I plug in the negative 2 here, I'm going to get minus 2k. Now look, you might be going, are you kidding me? I don't know what 2 to the 8 is. Well, I don't either. So let's just go ahead and work with it. So I'm going to get rid of all these negative signs. Okay, we'll distribute this negative sign through. So I have 2 to the 8 over 8 plus 2k, then minus, you guys, a negative 2, this little guy right here, a negative 2 raised to the 8th power, okay, that negative is going to go positive, right? Every time you raise a negative to an even power, it's going to go positive. So this is just the same thing as saying 2 to the 8th over 8. And then a negative times a negative is a positive 2k equals 16. So the nice thing here is that these two actually canceled out, so I didn't have to evaluate it. So then you get 4k equals 16, which means that k equals 4. So the answer is D. Okay, definitely know how to do 31. Okay, so this guy, I have no idea where I'm going to put this work, but it's okay. So first things first, set this equal to 0 for absolute value. This thing is going to split at 1. So we have this integral that's going from 0 to 3, but I need to split it at 1. So it's going to be the integral from 0 to 1 of x minus 1 plus the integral from 1 to 3 of x minus 1. But remember, because this is absolute value, I need to take the absolute value of each of these after I evaluate them. Okay, so finding the first integral there, the integral of x is x squared over 2 minus the integral of 1 is just x. And that's being evaluated from 0 to 1. And then plus, again, this is going to be x squared over 2 minus x. It's the same equation, so it's going to be the same integral, but then the boundaries are different from 1 to 3. And again, remember, I'm going to have to take the absolute value of each answer. Okay? If I keep going with this, checking out this one right here, you guys, the 0 on this one is going to 0 it out, so I don't have to plug that in. So I'm going to get 1 squared over 2, which is 1 over 2, and then minus 1. Don't forget the absolute value. And then plus, then I'm going to have the absolute value, and I'm going to have top minus bottom. Okay, so let's plug that in. This is going to be 3 squared over 2, which is 9 over 2, minus if I plug in the 3. Then if I plug in the 1, I'm going to get 1 over 2. And then minus 1. Okay, so on this first little part, 1/2 minus 1 is negative 1/2. The absolute value of negative 1/2 is 1/2, so I have that. Then on this part, let's break this up a little bit. So I have 9 over 2 minus 3, distribute the negative, minus 1 over 2 plus 1. So that gives me 1/2 plus absolute value of 9 over 2 minus 1 over 2 is 8 over 2, which is 4. Then I have 4 minus 3 plus 1. So what does that equal? So this is 1/2 plus 4 minus 3 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. So this is going to be 2 plus 1/2, which is going to be 4.5, right? No, not 4.5. Oh my gosh. 2.5. Good grief. That's 2.5. And if you write that as an improper fraction, that's going to be 4 plus 1 is 5 over 2. All right, so that should be D. Make sure you know how to do something like that. Something like that's on your test. Okay, number 33. So let's do U sub on this guy. What do you think your U is going to be? So the U in this case is going to be a 3x. That means your du is going to be 3dx. Okay, so if I do the substitution, I'm going to have the integral. Don't forget to change your boundaries. If I plug in a pi over 3 here, 3 times pi over 3, the 3's cancel out, leaving me with just a pi. And if I plug a 0 in there, that one's easy. 3 times 0 is 0. And then doing the U sub, I'm going to get the sign of U. The dx is going to become your du. I have a leftover 3, so I'm going to multiply by 1/3. Okay, now, so this is 1/3. The integral of sine is negative cosine of U, evaluated from 0 to pi. And you guys, I'm going to go ahead and put that negative on the outside here, so it's really negative 1/3 cosine of U, evaluated from 0 to pi. Okay, so let's plug this in. This is negative 1/3 times cosine of pi minus the cosine of 0. Now, cosine of pi, that's all the way on the left side, that's equal to negative 1. So it's negative 1, and minus cosine of 0, that's on the right side, that's equal to 1. So this is going to be, if I keep going, negative 1/3 times negative 2, which is positive 2/3. So your answer is going to be D. Okay, let's look at 33. So you have a continuous function on the closed interval 0, 2. It says the function f of x or y is between 2 and 4, then the greatest possible value of the integral from 0 to 2 f of x dx is. Now remember, if I don't know what f of x is, you guys, this just means area under the curve. Area under the curve. It's kind of a funky little question, but let's draw it out. So it wants the area under the curve from 0 to 2. So from here to here, right? 0 to 2. What does this curve look like? I have no idea, but I know that its y values are between 2 and 4. So between 1, 2, 3, 4, between y equals 2 and 1 equals y equals 4, this function exists, okay? So maybe it looks something like, I'm just totally making this up, maybe this function looks something like this, right? The lowest is 2, the highest is 4, in which case the area under the curve could be that. But look, it wants the largest possible area. So what if it looked like this? That's larger. That's a larger area. Can I make it even bigger? Yeah, how about if I did this? That's the biggest area that I can make, right? The biggest the y value can be is 4. So let's make it the biggest it can possibly be. This is just a rectangle with a base of 2 and a height of 4. 2 times 4 is 8. Kind of a silly little question. Okay, is that one whole page? Just hang on, I need to look. Yeah, I think I did the other one last night. Okay, let's see if I can get another page in because we did some of these already, okay? So 34, the average value on the interval 0 to 2. Okay, so average value, 1 over b minus a, integral from a to b, right? I even put that formula in there for you guys last time. Okay, so let's go ahead and do it. Let's plug it in. So I have 1 over, this is your a, this is your b. So b minus a would be 2 minus 0, which is 2. Integral from 0 to 2 of your function x squared square root of x cubed plus 1. Now you guys, look, you've done this before. It's just now you're doing it with the u sub. That's the only difference here. So let's go ahead and do u sub on this. So let's let your u equal the inside of that square root. That means your du is going to be 3x squared dx. So this is now going to be 1/2. Let's change our boundaries here. If I plug the 2 in, 2 cubed is 8, 8 plus 1 is 9. If I plug the 0 in, 0 cubed is 1, 0 plus 1 is 1. Okay, now doing the u sub, I'm going to have the square root of u, because all this became the u. And then look, the x squared dx, that becomes the du. But I have this left over 3, which means I have to multiply by 1/3 on the outside. Yikes. Okay, so now on the outside, I have a 1 over 6. Okay, and this is the integral from 1 to 9. Square root of u is really u to the 1/2 du. So let's integrate this guy. So this would be 1 over 6. If I add 1, I'm going to get u to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3. And I'm evaluating that from 1 to 9. So going to run out of room. Okay, this guy is 2 over 18, which is really 1 over 9. U to the 3/2 means the square root of u cubed, and I'm going from 1 to 9. So this is going to be 1/9, and then I'm going to have the square root of 9 cubed minus the square root of 1 cubed. Okay, now you guys, doing this, we talked about this in the last unit. The square root of 9 cubed is way too big to do. So instead, what I'm going to do is I'm going to take the square root of 9 and then cube that. Okay, I'm going to reverse the order. So the square root of 9 is 3, 3 cubed is 27. So this would be 1/9 times 27, and then the square root of 1 cubed is just 1. So this would be 26 times 1/9, which is 26 over 9. Okay, so that answer would be A. Okay, now you guys, I believe like in the second video, I did B with you. I'm sorry, I did number 35 with you. In the second video, I also did number 36 with you. I did not do 37, so let's do 37, but I did do 38. So let's finish 37. Okay, so this one right here. So I have the integral of something's 18. What is k? So just integrate it. Let's see what we get. So the integral of 2kx. 2k is just a constant. So this would be 2kx squared over 2 minus, and then the integral of x squared is x cubed over 3. I'm evaluating that from 0 to k, and the answer should be 18. Okay, so this cancels out. If I put the 0 in, it's going to 0 everything out, so I can get rid of that. So let's just put the k in. So if I put a k in here, I'm going to get k times k squared minus, this is k cubed over 3. equals 18. So what do I have left now? Do a little arrow there. Sorry, this is an 18. It looks like a bug. Okay, k times k squared is k cubed. So k cubed minus k cubed over 3 is 18. Now, you guys, if you don't like that 3, you can totally multiply everything by 3, or you can just put this over 1 and make a common denominator. So the common denominator here is 3. So if I multiply both of these by 3, I'm going to get 3k cubed over 3 minus k cubed over 3 equals 18. So now that I have a common denominator, which is 3, 3k cubed minus 1k cubed is 2k cubed. That equals 18. And then to solve this, I'm going to go ahead and multiply both sides by 3 to cancel out the 3. So I have 2k cubed equals 54. If I divide by 2, I'm going to get k cubed is 27. And then if I take the cube root, I'm going to get that k equals 3. Okay, and then that answer, I believe, was C. Okay, so there's page 7 and 8. And then you guys, I'll try to get 9 and then the last bit of 10 done for you guys as well. All right, I hope that helped. See you guys tomorrow.